Hi everyone. Today in this video I'm going to discuss thermodynamics. Thermodynamics. So in thermodynamics we're going to cover the zeroth law of thermodynamics, the first law of thermodynamics, the second law of thermodynamics, emphasizing on the concept of entropy. We are going to cover the Maxwell's relations in thermodynamics. Okay, this first law, second law, entropy, and Maxwell equations. These four are only important for your examination point of view. You'll get mainly questions from this four topics, and also you have a statistical part. I'm also going to cover that. It's a booster for you. So so let's start. We're going to first start with some basics. You have studied this in your high school, so let's have a recap of that. Extensive and intensive quantities. What are extensive quantities? Extensive quantities are those which are mass dependent. Okay, like volume. Okay, so what depends on volume is extensive quantity, and what is intensive quantity? That does not depend on mass. Okay, so how you can remember this concept? See, you can cite the example of EVM. Okay, what is EVM? You know that it's widely used during the elections. You can easily remember that EVM. See, volume, the example is within it. E for extensive, V for volume, and M for mass. Mass is also obviously an extensive quantity. So in this way you can remember this, that extensive quantity depends on mass, and with an example of volume. Okay, easy, right? What is intensive? See, I, it begins with the letter I. Okay, so I means independent. Yeah, so hope you can remember this. I'm citing for some examples. You may write if you are noting down. uh, so extensive quantities are mass dependent quantities, and for example you have volume, mass, etc. And intensive quantities are mass independent quantities. For example you have pressure, temperature, density. Okay, these are all intensive quantities. So this is the basic of extensive and intensive quantities. So let's go to the concept of zeroth law in thermodynamics and the definition of temperature from it. Okay, so let me use the next page. Zeroth law. Okay, one question is very important, that which physical quantities example uh, arise from the concept of zeroth law. That will be okay. Sorry. It is temperature. Okay, the physical quantity that arises from the zeroth law is temperature. So what is zeroth law? Suppose we have a metal A. We have this metal, and we have this metal. This we have gone through it in class 11 12, I am assuming, but okay, let me explain you from very basics. This is A, this is B, this is C. What's the definition? It's very interesting. If A and B are in thermal equilibrium with each other, and B and C are also in thermal equilibrium with each other, then A and C will be in thermal equilibrium with each other. Okay, I repeat, if A and B are in thermal equilibrium with each other, if B and C are in thermal equilibrium with each other, then A and C will be in thermal equilibrium. This is the concept of the zeroth law of thermodynamics. Okay. So when two bodies will be in thermal equilibrium, you are preparing for competitives. Okay, so you don't have to make exact statement that if a body is in thermal equilibrium with a second body, and second body is okay with third body, then the first and third will be okay. You don't need to remember anything like this. Just have the concept in your brain. That is enough for competitives. And yeah, if you are seeing for graduation or for your undergraduation, whatever, so you have to write it in a 2 or 3 lines in a good way. That is important. So the quantity that uh, arise from this, I'm telling it many times, it's temperature because it's important. How? Suppose we have three bodies, A, B and C. Suppose A and B are in thermal equilibrium, that is, they should have the same temperature. Okay, not heat content. Okay, you have to follow the concept of specific heat in this case. Two bodies having the same temperature might have different heat content, but when we say thermal equilibrium, they are under same temperature. Okay, so A and B are in thermal equilibrium, so they have the same temperature. Because what is the definition of specific heat? Heat required to increase the temperature of a 1 degree centigrade of a unit mass is known as specific heat or gram specific heat, or like this. So we might have two different bodies. We might have two different bodies having different temperatures. Sorry, having different specific heat, having the same temperature. Okay, these are very basic things. We people have gone through it in our class 9 or 10. I think I have studied in class 10 in my board. So yeah, so the same concept. That so this is important, that in thermal equilibrium two bodies should have the same temperature. So A and B in thermal equilibrium, B and C in thermal equilibrium, A and C will be in thermal equilibrium. So the concept of temperature comes from this law, zeroth law of thermodynamics. Okay, so let me do in this video that what is the concept of state function and path function. Any physical quantity that depends on the path it has gone. Suppose we have a jar like this. This is a piston, frictionless piston in ideal case. These are gas molecules. Okay, so you know what is work? Work is equal to force into displacement. You people are physics students, you know this. Force into displacement. So this is work. If you give a little amount of force and it goes a distance of delta x, then f dx will be the work done, and it depends on the path it's going. Okay, okay, so this is a path function. That is, you have to consider the path, or especially in thermodynamics, work is represented as force, sorry, pressure into volume, you know, pdv. That work done equals to pdv. And if you draw a PV diagram, pressure and volume diagram, this and this is 1, this is 2, this is 3, you know, pressure equals to p into v, that's pressure into volume. So you know how to find the area under the curve. You just have to take this tree line and find this area. For 2 you have to find this area, that is area under the curve. You have to take this entire area. You will know this in course of time, and many of you know this, I know. So obviously the work done in path A is greater than, because then 2, then 3, right? Because the area under the curve for 1 is greater than 2 and 2 is greater than 3. So it's path dependent. Same case for heat. Okay. And what is state function? State function doesn't depend on the path the system has followed to reach from its initial to the final point. Okay. Suppose internal energy, like entropy, like this, we write E u2 minus u1, and suppose entropy, we write S2 minus S1. This is the initial, this is the final. Same case for here. So these are state functions, depends on the state only, final state or initial state, like this. So I hope the concept of zeroth law, temperature, extensive and intensive quantities, and all what I said, yeah, path function, state function, all these little concepts are clear to you. Okay, so we are meeting in the next video. Thanks a lot for watching the video. Thank you.